Black holes are regions of space where the gravitational pull is so strong that nothing, not even light, can escape. Rather than empty space, black holes are chock full of matter that gets squeezed into a teensy space. Stars produce light and heat due to the engines at their cores, where a process called nuclear fusion occurs. There, two lightweight atoms fuse together to form a heavier atom, a process that releases energy. Those heavier atoms then fuse to form even heavier atoms, and so on to keep the star churning out light and heat. As such, when stars that are more massive than 8 times that of our Sun near the end of their lives, they fuse heavier and heavier elements in their cores, like silicon and magnesium. Eventually they start forming iron. The problem? Fusing iron requires more energy than that reaction produces, and so at that point nothing can counterbalance the inward gravitational pull of the star's own mass. And so the hefty star collapses in on itself. With all that crushing gravitational weight, the star's core gets squeezed beyond the Schwarzschild radius, at which point a black hole is formed. The black hole in Cygnus X1 has a mass about 20 times that of the Sun, which is pretty typical for black holes throughout the universe. In our own galaxy, scientists have identified anywhere between 10 million and a billion black holes. Black holes are just that. They're black in that they do not emit any light, but astronomers can still detect them through both the gravitational effects they have on other objects and their messy eating habits. For some black holes, primarily the supermassive ones, astronomers can see them because of the quasars they produce. Quasars are intensely bright sources of radio emission. When matter falls onto a black hole, it gets compressed and heats up in a souped-up version of Cygnus X1. Another way to see black holes is when they merge. When two black holes collide, they send out ripples in space-time known as gravitational waves. These waves are incredibly weak, but sensitive instruments on Earth are capable of detecting them. To date, astronomers have identified 50 black hole merger events.